Welcome to those people who are just joining us. We'll just wait another minute or so as Kirsten lets a few more people in. Okay, Kirsten, shall we make a start?
Yeah, that sounds good.
Well, good afternoon, everyone, and welcome to the second chain event focusing on engineering behind COVID. I'm your host, Dr Helen Meese, and I'm a chartered mechanical engineer with the IMechE, and I'm a member of IPEM as well. I'm vice chair of the institution's biomedical engineering division and CEO of the medtech consultancy company, The Care Machine. Today, we are joined by two outstanding engineers who, through their contribution to infrastructure engineering and medtech, have ensured that the initial COVID response in 2020 was a successful one. Our first guest is Dr. Antony Robotham. Tony is an associate professor of mechanical engineering at the School of Engineering, Computing and Mathematics at the University of Plymouth. His specialized interests include engineering design and new product development in automotive, aerospace, and renewable energy industries. And he has won numerous awards for his research work, but most notably, he won the Royal Academy of Engineering's President's Special Award for Pandemic Services in 2020 for the development of an environmentally friendly face mask, which is manufactured from recycled materials and is fully compostable and recyclable. So thank you so much for joining us today, Tony. I'm really looking forward to hearing more about what you've been doing during the COVID response.
Okay, well, nice to be here. Well, okay. Do you want me to do my presentation now, Helen?
Absolutely,
Or...
yeah,
okay,
if you
right,
mind.
okay, I'll share my screen now. Okay, can everybody see that? Okay.
That's great.
Okay, thank you. Good afternoon, everybody. Thanks for that introduction, Helen. Quite embarrassing, really, when you hear your own CV being read back to you. But today, I just want to share my experiences that started just over a year ago now in the development of the recyclable face shield. For those of you who don't know this product, then let me share a little bit about this. This is actually the product it being shown here by one of our models, one of the members of staff of the company that actually manufactures this recyclable face shield. Just a few points about this. The most important thing, I think, for everybody here today is to recognise that whilst this is, as you can see, it's a cardboard-derived face shield, it's actually been carefully designed to meet the British Standards Institute's standard for PPE, which is around healthcare professionals. It's a standard that was developed and modified especially for the pandemic requirements, and it's around particularly about eye protection for COVID care health workers. So this was a key for me as an engineer, but we had a product that actually could go frontline staff and able to be used in those frontline scenarios. The other thing clearly is that, as we'll come on to, this is a low cost but very high volume manufacturing PPE option. And of course, as you all know, there's the number and requests for PPE is significant volumes of equipment for healthcare workers were required about a year ago. And then obviously, as Helen's already said, the other aspect and quality of this product is that, of course, the materials can be recycled or if need be, composted to actually minimize any negative impacts on our environment. So actually it was first conceived over the Easter weekend last year, so just over a year ago on the 11th and 12th of April, me digging in the garden and having time to myself and thinking through some of the things that we were experiencing at the time. Then the design and development continued at a pace once I started to develop this first prototype and share it with a local company here down in Plymouth called Prestige Packaging. Now, Prestige Packaging, principally, they make the sort of cardboard containers for foodstuffs or for actually packaging of pharmaceuticals. And so this was ideal as a company to work with when we're dealing with these sort of cardboard-based materials. And as a consequence of that collaboration, within about a space of 2 weeks, this was the initial production run of around 20,000 units of the face shield. And you can see we're using print technology, and as it's a flat form here, it is ready, flat packed for delivery. And then every face shield is a 3-part piece that is then individual people can put together. And then going back to that BSI standard, we actually had the product tested and approved by the 13th of May. So as you can see, this product went from an idea in my head right through to technical approval in a space of around 4 weeks. And that's the important thing given the major concerns at the time in that pandemic. Obviously, the key features when you come from a design perspective is that what's its primary function. So we're all, as engineers, when we design any sort of product, we obviously need to understand what's its functionality. So of course, one of the primary functions of this PPE equipment is to provide protection against contamination to the eyes. And this is the key difference between a face shield and the face mask. And in the first image you saw, you need to still be wearing face masks in combination with a face shield, because the face shield is actually about preventing contamination of the eyes. It is not the same as a function as what a face mask doing, covering the mouth and the nose. So this is something I think you need to appreciate, and maybe more generally in the public, as people are wearing different forms of PPE currently, as to what the real purpose of a face shield like this truly is. And obviously, as you see here, utilizing computer-aided design tools, very simple models of the face shield, but it was important to actually evaluate their performance against what is the British standard 50 percentile adult male reference head form. And this was the head form that the PPE standard referenced as the visor needed to protect the eye region, shown by the rectangular region A, B, D, E. So you see AD here, and you see A, B, C, D here. So using computer-aided technology, I was able to validate that this eye protection was given to this region. So it's not just on the front, from the front, but also from the side protection. Again, this was an important aspect of the design to ensure that this protection is provided. And obviously then, once we had our first production run, the 6 samples were sent off to the British Standards Institute for testing. And as you see here, this is the face shield actually on the 50 percentile reference head at British Standards Institute in Milton Keynes, and being tested and evaluated. They send lasers to the eye forms and to see whether the actual shield gives the protection required. Just from the other aspects of its structure, it was 3-piece parts. The frame and the strap are separate pieces, and they get mechanically locked together. You can see the lock tabs here, part of the actual mechanism for assembling the two elements together. They're made of a box board, which is a technical cardboard, so it has a particular functionality associated with food products. So it's a sort of cardboard you get in your sandwich packs. And so it's not just any old cardboard. This is actually a technical product made to a rigorous sort of specification. And it is 100% recyclable. It can be compostable if you wish. And in this case, again, from its point of view of environmental values, it's made from a certified wood product, so FSC certified wood products. So the source of the material is from a sustainable source. And the inks that you see here, they're all printed using vegetable-based inks. So again, a very low impact on the environment for the printing that's required. The visor itself, difficult to see here, but you see here, again, there are technical requirements, and two technical requirements from the brief are that it needs to be an anti-fog and anti-glare. So again, this is requires a technical product, and the technical product here was a hot span PET product, clear polyester film, but again, was cut and then assembled onto the actual face shield frame. It's attached using a pressure bonded adhesion during the production process, and little dots of adhesive are applied during the printing process, and then these dots allow the actual PET to be peeled away at the end of use so that the two material types can be easily separated. Again, this can be 100% recycled and returned into the production cycle. And this is something that Prestige Packing themselves are able to do. The production is Prestige Packaging is sort of used printing techniques. They have cut and crease presses and window patching equipment, and they're approved to meet the sort of global food standard safeties for obviously food packaging and similarly for pharmaceutical packaging. This is a flexible manufacturing system, so they can, within about 20 minutes, can migrate from doing face shields back to doing sandwich boxes or cartons for pharmaceuticals, or cartons for some of the high value add products that are made down here in Devon and Cornwall. And of course, what we were looking for is potentially units of about 100,000 units per week as a potential production that was achievable through this facility alone. So that's the product, how it's made, but just wanted to spend a little time before we finish just reflecting upon where did this all come from and what were the triggers for this idea and for this product. Well, of course, naturally, this time last year, we were in the middle of a lockdown, first lockdown, and the COVID pandemic was obviously going global. And every day we were getting this media telling us that there are PPE shortages in the National Health Trust, principally because the supply chains from China had virtually shut down because of what was occurring in China at that time. So there was real concerns about PPE shortages in the NHS. And then another trigger for me locally here in Plymouth, colleagues at the university coupled with a number of the major manufacturing plants here were engaged in a 3D printing program, printing these plastic face visor frames. Now, my experience of 3D printing goes right back into the mid-1990s. And I understood from that whilst we used to call it rapid prototyping, we now call it sort of 3D printing. There's still a limitation to how many units can be made through this process. In the context of maybe product development, it's still a rapid prototype in process. It's a rapid prototype for creating individual items. But when you're starting to look at the volumes that were required, my concern was that it just wasn't the volume there through these printers working continuously 24/7 as they did for about 4 weeks in the city. and I think in total they produced about 6,000 frames. The environmental concerns obviously around the use of plastics, and particularly if these were going to be single-use plastics, which as any of you will know in the NHS, a lot of equipment has to be used and then immediately disposed of and is not actually reclaimed and utilised the next day, as we might have done many, many years ago. A lot of equipment, PPE, is single-use equipment. And of course, there was just that personal frustration of being homebound and having time to think about this challenge. I think the other thing that's important here to reflect upon through this project is the importance of collaboration as engineers. You know, for me, I might have the motivation and I was maybe the initial trigger and the initial concept. The university very quickly agreed to some pump priming money, and that money secured one of only 3 rolls of the PET plastic that was used for the visor that were in the country at the time, and actually obviously then working with Prestige Packaging, they had the expertise in the cardboard technology and the production capability, and ultimately they were responsible for the realization of the product as a physical artifact as shown here. So that's an important aspect of this project for me. It couldn't have been achieved without the collaboration and enthusiasm of Mike Corran, who you see here from Prestige Package, and his team. Finally, this project, as you've already heard, has got some peer recognition, and alongside all those other recipients of the Pandemic Award from the Royal Academy of Engineering, you can find all the material at the Science and Media Museum at this website. And as already been said, it's quite a nice surprise for me that the work was appreciated and recognised and valued for really it wasn't what we were motivated by. The 3 of us here, Mike, Dave and myself, were just motivated by doing something, feeling like we were doing something to help out in the COVID pandemic. Okay, thank you for listening.
Thank you ever so much, Tony. And it's really nice to hear the story behind that award as well. You know, we saw many of the recipients, you know, presented at the Royal Academy, but it's the story behind it that is so inspirational, really. So thank you for that. I'll just start with a few questions, I think, and just drawing on what you said about your triggers for doing this. You know, when COVID first hit, I think just about every engineer said, you know, what can I do to help? I was getting phone calls on a daily basis from people just wanting to volunteer. So what kind of spurred you on to take that action? You said you kind of had the inspiration while you were gardening, but was there anything that drove you really to think about this?
I think, as I said, I think there was those constant sort of messages coming through the news every day about the challenges the NHS was having. And then it was actually really hearing about what my colleagues were doing at the university in printing those, using 3D print technology. And as I said, my knowledge of 3D print technology goes back many, many years. I actually operated a centre in one of my previous universities. We did a lot of 3D printing for introducing this technology to companies. So I fully understood its capability, but equally its limitations. And I well knew that there was a lot of time and energy going to be taking place, you know, using 3D printers, and that you just wasn't going to get the volume up. So that was a concern to me. How do you get the volume up? And at the University of Plymouth, there's a part of our DNA is very much raised around marine plastics and the pollution created by that. And I myself were actually actively involved in a European funded project around how we can deal with marine litter in the plastics and repurpose it for something useful. So all of these things you go through your mind. And I suppose, you know, that classic eureka moment, I don't know how it always happens, how it occurs, but I'm sure, you know, I've seen many people with great ideas, but it's not very often you have your own eureka moments. And I think it's just that combination of things, and the frustration maybe of being at home and the only thing I could do was dig the garden. Didn't sort of sit true with a frustration of not being able to do something.
Yeah, well, I think that goes for many of us who were all desperately trying to contribute in some way or other to support the whole process. I'm very interested in what you said about the nature of the materials and so on, and I wanted to ask you about the wider impact for your mask and the potential for manufacturing this kind of frugal technology in low-income countries. We're seeing now as the resurgence of the pandemic in India, and they're desperately trying to get equipment over there to support that. So do you think there are opportunities for this kind of sustainable technology to be translated easily to suit manufacturing methods overseas?
Well, absolutely. As I said, I think the thing here was that yes, we're using some very sophisticated, flexible manufacturing system here. Prestige packaging have about being able to migrate from one product line to another and do very short print runs. But those short print runs are tens of thousands of units. And I think but it is basically sort of print technology, and I think that's prevalent around the world. It's not, so that's the important thing. And of course, cardboard is prevalent around the world, and it doesn't necessarily have to be made from these high spec products, because that's the sort of physical frame. And again, it comes down to, well, we were keen to actually achieve a standard. So again, that's why we had to have the high spec anti-glare, anti-fog PET product, because that's what the standard required for healthcare workers. So the motivation was to get it from, as the British standards describe things, this cottage industry that everybody making these things, to a product that is technically capable and therefore safe for people to use. I think that it can migrate, and the frustration I have, I guess, is that I did a lot of work trying to contact and engage agencies, with here's a potential solution. The challenge is how do you make that next step into it becoming a broadly utilised technology?
Yeah, there's a whole conversation there around patenting and all kinds of other things that we perhaps have to say for maybe another conversation. But I wanted to ask you, as a lecturer yourself and having been teaching for a very long time, what would you say to any of the young engineers listening today who've identified a problem or a challenge, but don't necessarily have the financial backing or maybe the support to help them deliver it? And what would you do to encourage them to make that idea a reality?
Well, I think as I also said in the slide, I think it's about trying to find collaborative partners, and it's any expertise, and my role in the past, I've sort of alluded to that in the past, is actually being director of sort of product design and development facilities to enable small companies to help them in developing new products. And it was a case of having a broad set of skills. So I had people in marketing and business, I had product designers, engineers, manufacturing specialists. I actually had a specialist manufacturing kit with a lot to demonstrate technologies. So we sort of filled that hole, which sort of enabled people to sort of find skill sets that they were missing. And I think through collaboration, you get all those different skill sets. And again, just in my network of former students, so a student I taught 20 odd years ago, he runs his own automotive design and development company. He was one who responded to my LinkedIn sort of, look what I'm doing, and can anybody help? And he said, hey, I can get you in contact with these guys. And we were put into contact with a large group who were trying to establish PPE supply to the UK. And we can have a long conversation of the challenges of that. obviously in the news recently, we've got a lot of information about Dyson and their sort of desire to supply into the UK market a new product. And yeah, there's a lot of stories, I think, around maybe what didn't happen as opposed to what did happen and what did happen. There are lots of success stories, but there's lots of frustrations as well, I think.
Yeah, it's surprising the number of little businesses that did kind of appear and pop up just from this wanting to solve this one problem. So I think that's great encouragement to anyone listening today who kind of wants to be entrepreneurial about problem solving.
And there were lots of people, entrepreneurial people with the resources to wanting to do that, and they were looking for those ideas to invest in at that time. So yeah, if you've got an idea, get it out there, share it, but protect it.
Yes.
We didn't worry about protecting. There's no protection on this because the most important thing was the solution being out there.
Yeah, absolutely. Now, I guess the last question I'd like to ask you really is what are you planning to do next? You know, are you looking at other PPE medical devices that could benefit from being designed in this kind of sustainable way and using sustainable materials? And you know, and what's next for the mask, really?
Oh, yeah, I think there's two questions there. I think the mask, what I'd say there is it's out there now. It is a product that's out there, and it's proven it can fulfill its technical objective. I think with a lot of new products, you just maybe have to wait your time, and you know, eventually products start to get, you know, taken up and recognized. We haven't invested a lot of time in trying to promote the product and get it out there. It's not a priority. Mike's got his other business to run and ensure he keeps his small business going. And you know, I've got my students to teach online at the moment. So it's there, it won't go away. I think the other question is, the irony is, for me, is a couple of months after this whole project, I myself were in hospital having surgery. And yeah, I very much experienced firsthand the amount of plastic products that I were given just to take home and bring home for my recovery from surgery. And yeah, the consultant, once he picked up that I had done this project, started to badger me about what can you do with this particular product that costs us a lot of money. And yeah, I'm sure there's more to be done. It's just finding the time.
Well, I'm sure even if you can't find the time, Tony, I think you've probably inspired quite a lot of people to take up the challenge in COVID and in other problem solving areas. So thank you very much for joining us today, and thank you for your presentation.
Most welcome, and it's been a great project to be part of and still ongoing. And I'm sure my colleagues at work have been fed up of all the pictures of face shields and the publicity that it's brought and the interest it has brought as well.
Oh, that's great. There's nothing wrong with publicity, that's for sure. Now, our next speaker is Major Matt Fry. Matt has 16 years of service with the Royal Engineers and has conducted operations all around the world, ranging from IED disposal to the delivery of technical infrastructure in very austere conditions. Most recently, he was the commander of the military assessment team responsible for the delivery of the Nightingale Hospital in Manchester, delivering a fully functional NHS hospital in just 12 days. Even with the rigours of his day job, Matt continues as well to support and be a catalyst for positive change in the promotion of STEM to young people. We are very pleased to have you here with us today, Matt. Thank you so much for joining us. I know that you've got a few presentation slides, so please, over to you.
Fabulous, thank you. Can I just confirm that you can hear me okay and see the presentation?
Yeah, absolutely.
Perfect, thank you. Okay, thank you very much for that introduction. It is very, very kind. One of my first slides was actually based on a quick overview of my career in the military. That's not particularly relevant, the bits that are relevant are the fact that I'm a chartered civil engineer within the military. We deliver infrastructure worldwide. And on operations, we have to work in conditions where we don't have all of the information that we would like. We have to work in uncertainty. Every decision that we make is a balance of risk, and that gives us a slightly different perspective on engineering problems and challenges, especially when it comes to a crisis. So working in uncertainty and being comfortable in working in uncertainty is kind of the element that the military was bringing to this situation. I'll start in the same way that Tony did, with a bit of a timeline to show context. So this is sort of the overall picture of what has happened from the beginning of COVID through to almost where we are at today. And I just want to focus on 23rd of March, which is when the announcement was made that we were going to go into lockdown. And behind the scenes, all of the data analysts had been processing the data. And the theory at that point was that the NHS was going to be overwhelmed by a peak of cases, given the current trends in the middle of April. So that gave us this tiny, tiny little window in which to actually generate a national response. And in that time, even as I look back at it today, there was a 20-day window from me receiving a phone call to say, Matt, we need you to get your team ready and deploy to go and do something, we don't know what yet, through to having built a hospital and having received the first COVID patient. So that was from not even knowing where we were going to build through to having a completely functioning hospital in a 20-day period with a 12-day build time. So where did that all start and how was it coordinated? There was a team in London that was working with the NHS, looking at the national situation and trying to figure out where we need to deploy the response. And we had geospatial engineers working with them to look at the regions, areas, locations where we needed additional support. My team was nominated to go to the Northwest, and we were told literally, we need you to build between 500 and 1,000 ventilated bed spaces in the Northwest, and that was my mission. First thing we did was hit the road. This is the M1 with no traffic on it whatsoever. It's very strange to look back and remember what that first lockdown looked like and how strange it felt to be literally the only people authorised to be freely moving around the country. First location that we looked at was the Manchester Arena. My assessment of this was that this would be kind of a bronze level solution. Second, we looked at Manchester Central, and the assessment there would be that this would kind of be the silver level approach. And then the third location that we looked at was Event City, which would have been the gold standard in terms of deploying a hospital. Now, what we were looking at the event locations because they're easily configurable. They are designed to have power and water and drainage. Basically, you can position that anywhere within those buildings so that they can host the expos, etc. Now, as it came down to it, there were political reasons for choosing locations, and there were also financial reasons for choosing locations. And in the end, it was Manchester Central, the silver level in the report, which was chosen and justifiable because of the cost and the sort of limited political impact that that would have. So that was technically my job done. Go out, look at the places, make recommendations on where we could build, then the NHS will decide which one they want to build on. So this was the NHS team that I met with. They were a small group of maybe 7 or 8 individuals that had all been told, you're it, you're on point. And I was handing over this information and it became very, very apparent that they were clinicians, they were doctors, they were virologists, they were not project managers, and they were not construction specialists. And I essentially, I've got to be very careful how I word this since it's been recorded. My orders were to return to Nottingham and await further instruction. I managed to find a way of not returning to Nottingham and await further instruction so that I could continue to work with this team of individuals that needed that support. The activity that's going on at the table there, I'd literally ripped out, opened the pamphlet for the REBA process of works for how you build a project. And what individuals do you need? What responsibilities do we have? And it's literally on the back of a fag packet, post-it notes, who is meant to be doing what. And all of the yellow post-it notes are roles that need to be filled. The pink post-it notes are people that I've been able to identify that are currently filling those roles. So the group didn't even really have the organization or the structure in order to put this together. So I basically explained to them that they needed additional support in the following areas, that we needed contractors, we needed all of their subcontractors, we needed their suppliers, their logisticians, we need all of them in a room at the same time. And if we can manage that tomorrow, that would be great. And I was expecting maybe a handful of additional people. The following day, I was absolutely blown away. The request went out and people came. Every single person that was invited arrived. Now, what's happening now is we've got a whole bunch of contractors and subcontractors who've been asked to come and help build a hospital, who are now sitting in a room saying, well, what do you want us to do? Well, at this point, we have no design. We don't even know what the clinical model looks like. We don't know what we need to build. We know we need to build a hospital. So it was then my job to coordinate all of those individuals, find out what specialist skills they're bringing to the party, understanding in my head what the Gantt chart, what the sequence of works should look like, and then try and figure out what are the big levers, what are the things that must be done, and then filter out all of the detail and the nif-naf and just let other people deal with that. And the first thing that was obvious was that before we build anything, the first thing that needs to go down, we're going to need a clinical level flooring. And even though we don't know what the rest of the design looks like, we definitely need that. So let's start with it. By the end of that day, we'd managed to assign more people to roles, and we had a clearer idea of how we were going to move forward with the project. What I'm going to do now is switch to a video. Basically, I spotted up in the corner of Manchester Central, there was a CCTV camera. I asked the staff there to take a photograph every sort of 30 minutes. And what you'll see now is literally the following day after that meeting, when flooring has started to arrive. We've no idea what the actual design of the hospital is going to look like at this stage. And ultimately, there were about 3 or 4 different contractors that would ordinarily be competing against each other for work, all working together on this project, because the nature of it, that national effort, is bringing people together. By the end of the project, you wouldn't know who was working for who. It was all just one team. In the background to this, we've got a small team of people building sort of mock-ups and test bays of what the cube spaces are going to look like, and inviting the NHS staff to do rehearsals and work through it. The idea being that if we built those cube spaces too large, then we're not going to fit as many into this space. If we build them too small, we're not going to be able to deliver the level of care that is required. So it was about finding the optimum balance that would enable the correct level of care to be delivered whilst maximizing the number of bed spaces. So then we have you can see the partitioning starting to arrive, and how quickly that then goes up, and then it all gets laid out according to the plan that we'd come up with. Every day we were briefing what has changed on site, identifying what the critical factors were, what are the big decisions that need to be made. And I used the mantra big levers, because everyone was kind of overwhelmed with the amount of work that needed to be done, all of the decisions that needed to be made. And when you're faced with so much uncertainty and so much pressure and so much information, people can often suffer from sort of a lockup, a freeze, that they become paralyzed in making decisions. So it was really my job to kind of police the meetings and make sure that people stayed on track and that we were getting the right decisions from the right meetings at the right time. So what you've just seen go up in the video here, just up in the top right, that's a load of Unistrut beams that have been installed, and they were designed to carry the piped oxygen that was going to be deployed to every single bed space. Now, bearing in mind at this point, there is now a national shortage of O2 and O2 cylinders, and all of the designs had to be worked on the fly in order to accommodate the materials that we could get hold of. What you can see now going in as well is all of the data cabling. So every single one of those bed spaces is wired up for data comms, and it is then hooked into the NHS national mainframe. So they can allocate or choose any specific hospital, the regular hospitals, then including the Nightingales, and delve in and go to a specific bed space and know which patient is in there, what equipment has been in there, what care they're receiving, etc. So it wasn't just making a space to put a patient and wiring in O2, it was also getting it wired into that national mainframe as well. There are a number of issues that we had to sort of work around, and this is to do with legislation as well. And so I overheard a conversation about having to remove bed spaces because of fire compliance. And when we investigated it, the architects were trying to remove 49 bed spaces in order to make a corridor wider. And that was because it was 2.5 centimeters too narrow in the corridor. So for compliance, we have to remove the bed spaces. Well, my argument here at this point is, well, what's the bigger risk and what's the bigger issue? And it was very unnatural for the staff to then sort of press back to the fire controllers to say, look, we want dispensation to bend the rules a little bit because we need the bed spaces, and getting them to carry that risk was really, really important. So that gives you a feel for sort of how we rolled out and progressed that design. It's slightly deceptive when you look at the video because what you can see, it's a sort of fisheye lens. You can see the front main space, but that's equally replicated 2 more times in between the other partitions looking back. And to give you an idea of that scale, I will stop that particular video and skip to the next one. So this is almost, I think this was a day and a half before opening and completion. I did a walk through the hospital. So this is what patients would see as they were arriving. My apologies. Let's try that again. So of all of the Nightingale hospitals, you can see this is probably the nicest of all of them, being in an old Victorian train station. The copper pipes at the top is the piped O2 from the external tanks. All of the equipment was all sourced specifically for this location. IT for the staff, the wash stations, and at some point the camera will pan off to the right and you will see a number of doorways. Now what they are, that is kind of an airlock system. So there is to be no cross-contamination between what is known as the green area that is non-COVID and safe and the red area. So essentially the only people who are allowed in this area now into that red area are the trained staff with the correct PPE. There's no regular access to this space now. So all of the food and the medicines all come through that airlock system. Every single bed that you see, every single piece of equipment came flat packed. It all needed to be built and constructed. And so we ended up employing a workforce from Network Rail. So all the rail workers who were currently off work because of COVID were then employed to come in and build all of those. We mobilized additional military personnel to help us put those together as well. Another option or another perspective that the military bring as well is the consideration of security. By design, we're used to considering security at every stage of a project, and that was that's not necessarily a consideration on a normal routine project, but we were able to bring that to bear as well. So logistics was a big area where the military were able to help as well. And I suppose a more subtle one is understanding the importance of rest. You can imagine that throughout this, people are working very, very long days, and knowing when people need to go and get rested instead is really, really important. So what you can see there, that's finished on sort of the final plan, the final layout of the hospital. I'm aware that I'm just kind of on my 15-minute mark there, so I'll just switch to the key takeaways there. The first one is that the Northwest mission was slightly different to the rest of the country. What they were trying to do was have a step down facility. So when people have been to hospital, they're starting to get better, they're through the worst of it, that is when they would then come to the Manchester Nightingale Hospital. So the clinical model was slightly different and our mission was slightly different. But the one thing that brought it all together was a union of effort. I mentioned about how the contractors all just came together. There was no fighting, there was no contractual banter, it all just happened. And then the perspective that we bring as a military is a sort of empowerment of within the specialists, within the virologists, within the people that are developing the clinical models, working in uncertainty and working through that uncertainty. That's the way we work on operations. It's absolutely not the way that we would deliver normal infrastructure. I'll finish on just a final slide, which is a quote from one of the guys that was working on the top, that Rome was not built in a day, but we weren't on that job, otherwise it would have been. And at that point, I'm happy to invite any questions.
Matt, that is just a superb story, and you speak about it in such calm and gentle terms, but yet I know from my own experience, having worked at Nightingale London, that is not the nature of what was going on at that time. And we kind of look back now, I suppose, with in some respects with fond memories, but at the time, that blank sheet of paper was incredibly ominous, wasn't it? It was a real, what are we going to do here? And you've really shown just exactly what bringing a team together can do, and how engineering can impact on that. So it's really great to hear what you said. Now, I know you've talked about this in your presentation, but you're obviously very used to working on these sort of large, complex construction projects. But what kind of things were you focused on first? And you know, when that blank sheet of paper appeared, what was the first thing that you went through your mind?
So the first thing that we go through with any project is, what is the end state, what is the requirement, and what are the key components of that. And if you try to list all of the ingredients that make up a hospital, you'd be there all day and probably just feel slightly overwhelmed. But the key requirements were that it was between 500 and 1,000 bed spaces, each with O2 piped to it for the ventilators. So the big lever, and this is the terminology I was trying to get all of the team to use, was, where do we get the O2 from? Where's the best place to locate it? And how do we get that to the bed space? And the configuration of that, we've no idea at this stage. What we're doing is laying the tracks ahead of the train, which is, again, an absolutely upside down way of delivering infrastructure, but it's the only way that we could do that. So it's just about figuring out what are the key issues, and let's just focus on and worry about those. Because if you try and worry about everything, you'll become paralyzed. And yeah. I think one of the biggest things that I was able to do for the NHS teams who were feeling this, you know, they know the detail, they know how much needs to go into this, but, you know, just figure out what's the decision that needs to be made today. And if you can do that, you can sleep well at night and then approach tomorrow's problem tomorrow, rather than trying to do it all at once. You have to pace yourself and use the energy that you have appropriately and not burn yourselves out. And just having someone,
sorry, Karen,
just seeking that clarity and being calm and giving a presence of being calm in that uncertainty helped them to find their way through. And it was great to see their confidence levels grow to the point that I was essentially, by the end of the project, just stepping back. I was in the background, just allowing them to get on with what they do and what they do best. And they had the confidence. And it was nice to even hear them regurgitating some of the terminology that I'd introduced them to, and they were owning that and taking it forward. And that was really good to see.
Yes, I can heartily agree with that in terms of almost providing the facilitation rather than the this is what we're going to do. But sometimes it was more enabling them to be able to do the job themselves, wasn't it? And to kind of provide that facilitating approach.
Absolutely, absolutely. And I remember the first time that I was ever put under huge amounts of pressure and that feeling that I don't know what to do. How do I get through this? And it's only sort of through, repetition of being exposed to those kinds of environments and those situations that you know that you can get through it by the end of it. There is a way forward, and all we need to do is just find those big levers, pull them off one at a time, and work your way through it systematically. The detail will come, it will fall into place. It's understanding what are the critical catch points that you need to get right first. That's how we did it.
Yeah, well, that leads very nicely on to my next question, really, which was obviously your engineering background. That's the basis, the platform from which you've been able to do this work. But when it came to dealing with kind of the civil side of the project, how do you communicate and coordinate with the civil contractors to ensure that everything runs really smoothly?
Well, I suppose the benefit is that my day job within the Royal Engineers is very, very similar to how it would be for civilian contractors. We go through the same training. I'm chartered under the same rules, regulations. We work with contractors out on operations. The real difference on this project, though, was the usual contractual binds that we would have were kind of just overlooked. So yes, I want you to come and build a hospital. Yes, I want you to get subcontractors in, but no, I can't tell you when you're going to get paid, and I can't tell you what that's going to look like, or what the rates are, or etc., etc., etc. Because in the first days of that operation, that was simply an unknown.
Yeah.
But it was a national effort. People knew that there was a kind of a responsibility and a duty to lean into this. And so all I did was just use the same language and the same terminology as I would in my day job. The difference is that I suppose it was more of a leadership kind of element to it, to give people the faith and the confidence that we can do this and we can achieve it if we work together. So I think the difference was, it was more about leadership than the sort of engineering challenge. To come back to the original question as well, where you were asking about my engineering experience and how that came to bear in this situation, the decision to stay with that team was born out of that experience, and knowing that currently within that room, they didn't have the expertise or experience to be able to coordinate and pull all of that together coherently and quickly. So the reason for me staying there was to just allow them to cohere and then find their way and step off. And then I stepped back as soon as it was obvious that they were heading in the right direction. But experience is something that you can't buy, I suppose. It's we all have to find that our own way.
Yes, absolutely. I think as engineers, we were all drawing on our experiences to really come up with problem solving, whether it was designing masks like Tony, or building hospitals like you. We were all kind of driven by it, I suppose. I guess my final question to you really is, this kind of national mobilization is hopefully, fingers crossed, a once in a lifetime situation, not just for the military, but for all of us, I suppose. But what engineering lessons do you think have been learned by the armed forces from this experience, and how do those lessons get translated into practices within the military in the future, particularly, I suppose, both domestically and internationally in these sorts of crises?
So I suppose I've already mentioned that one of the elements that we're used to working in is uncertainty. We will never know everything about the areas that we're operating in or the conditions that we're operating in. So uncertainty is something that we're reasonably comfortable in. When we translated that into the sort of NHS context, and we've got, for example, a virologist who needs to help develop a clinical model but hasn't got all of the data and is reticent to make a call yet, but we're sort of forced into that situation where he needs to make a decision, but then the nursing staff need to make decisions based on that decision, and actually they're interlinked, and one decision will affect all of the others, and then we sort of part way through a meeting figure out that actually everything is interdependent on everything else, and people are just sort of coming to the conclusion, well, we can't do this. Well, the biggest thing that I learned from all of that is that if we can extract broad principles about what the solution would look like from each of us, not defining the solution, but the principles that lead us towards the solution, we're actually able to move forward by bracketing a left and right of arc, and find it. And once we identify that, if we broaden those left and rights of arc, that allows people to actually move to the next stage and make decisions, again, accepting that we will narrow those arcs further down the line. And that was really, really useful for me. And that is something that has stayed with me to the point that I'm now working on a dissertation as part of my studies, to look at what are the rules or procedures that we can use for delivering a project. So if we can define the rules and the principles and we can automate that, can that help us make quicker decisions in the future? So for example, if we took the clinical model of the COVID response to say that we need bays of this size, this kind of equipment, this many nursing staff per this many patients, this many sort of wash stations per X number of staff, etc., etc., etc. You can almost break that down into a rule set. And if we can then apply that using sort of modern software, modern technology, theoretically, I could go and recce any number of locations, define the parameters and the space that is available, and immediately, according to the rules, we would have a design that ought to be somewhere close. And then if we were to fast forward 10, 15 years and we have another similar outbreak, but it requires a slightly different clinical model, the theory ought to be that we can just refine the rules and click go. And there, essentially, that ought to save days off of that process, which again equates to a faster response, saving lives, etc., etc. So the big thing that I've taken from it is that ability to, I suppose, extract rules and processes and apply them more broadly, rather than having to define, as we do in a normal construction process, iteratively work our way towards that solution. There's faster ways that we can do that. So I'm doing some additional research to try and bottom that one out.
Well, it's nice to hear that you know, practical application has actually formed itself into an academic process which you are now studying. So it's really nice to hear that those two things are going hand in hand, that your work has influenced your further studies. So I look forward to seeing the outcomes of your dissertation. It would be great to hear how that turns out. Matt, thank you ever so much for taking the time out of clearly what is very busy time for you in the midst of your studies as well. It's brought back a lot of memories for me being involved with the clinical engineers at Nightingale London. So thank you very much for sharing your story and the incredible result of that. On behalf of obviously everyone at Chain, thank you very much to our guest speakers today. We haven't had any further questions, but of course, if you do have questions, please feel free to email the Chain team, and I'm sure we can get those questions answered. But on behalf of Chain and our guests today, thank you very much for joining us. Bye-bye.